Hello everyone, welcome to the class of analysis of Darlington emitter follow a circuit. In the last video, I explained you about the analysis of second stage. Okay, now I'll move to the analysis of first stage. Okay, so as usual, you have to check whether how to go for approximate H parameter model or exact H parameter model. For that, what you have to check? You have to check the load resistance of the first stage. See, the load resistance of the first stage RL1 is nothing but Ri2. See the circuit. Actually, for the second transistor, at the emitter you have Re2, it becomes the load resistance. But for the first transistor, load means, yes, the resistance at emitter, if there is any resistance at emitter, and the input resistance of the second stage. What is the input resistance of the second stage? Ri2. Okay. But here at the emitter of the first stage, the resistance is infinite, and in parallel with that, you have to take this Ri2. Okay. Emitter after E1. Okay. You have to check the emitter resistance as well as the input resistance of the second stage. That is Ri2. Ri2 in parallel with infinite gives Ri2. So that is the reason the first stage load resistance is Ri2. This Ri2 is, we already know what is Ri2. See this is Ri2. What is Ri2? HIE plus 1 plus HFE into RE. Yes, the minimum value of HFE is 50 and the maximum is 500. Okay. So now, even if you take 50 plus 1, 51, RE is about 2K or 3K like that. So 51 into 2K is 102K plus HIE 1.1K. So totally it is 103.1K, which is very high. So it is high. Okay. And as this is high, we can say this RL1 is not less than, it is not less than 1 by HOE. Okay. As RL1 is high, it is high. It is not less than 1 by HOE. So that is the reason we have to go for exact analysis. Means you have to take exact H parameter model. I explained you in the last video. Yes, if RL is less than 1 by HOE, then we have to go for approximate analysis. If RL is greater than 1 by HOE, means if it is not less than 1 by HOE, we have to go for exact analysis. Okay. And we know the Darlington pair circuit is a CCCC amplifier. So it is the exact analysis of CC. Okay. So CC exact H parameter model. But here the point is, yes, we are deriving this exact H parameter model. We are not directly taking the exact H parameter model of CC. Instead of that, we are deriving this exact H parameter model of CC from CE exact H parameter model. Okay, what we did for the analysis of second stage, yes, we got this CC approximate model from CE approximate model. In the same way, here also exact H parameter model of CC is going to be derived from CE exact H parameter model. Okay, so now I will draw the CE exact H parameter model. Yes, base, emitter, collector. Yeah, exact H parameter model. So between base and emitter, HIE, and there exists another parameter, a voltage source, HRE VCE. Between collector and emitter, we have two things again, HFE IB and also HOE. Okay, and here this is nothing but C1, B1, E1. So between C1 and E1, the voltage is VCE, IB1, and this is IC1. So this is exact H parameter model of CE. So now we'll draw CC exact H parameter model from this. Okay. Now I am drawing CC exact H parameter model. Okay. So what is the input terminal for CC? What is the input terminal for CC? B1, and output terminal is E1, and the grounded terminal is C1. Okay. So between base and emitter in the CE configuration, you have HIE in series with HRE VCE. Same I am connecting here. This is HIE and this is HRE VCE between base and emitter. Okay. And between collector and emitter, you have two things in parallel, HFE IB1 and HOE. So now, two things in parallel, and the direction is from the collector to the emitter. So it is HFE IB1 in parallel with HOE. Okay. So across this you have VCE. Okay. Between C1 and E1 you have VCE. So as this is plus and this is minus here, C1 plus and E1 minus. So I am taking the VCE like this. This is totally VCE, but this is plus and this is minus. Okay, and mention the currents. This is IB1 and this is IC1 and this is IE1. After E1 we have the resistance. What is the resistance here? This is nothing but RL1. RL1 is nothing but RI2. Remember that. Okay. So now for this circuit we have to find voltage gain, current gain, input impedance, output impedance, etc. First we will go for AI1. Okay, what is AI1? Output current by input current. See this? Even into the circuit the current is IE1, but through the load the current becomes minus IE1. So AI1 is the output current minus IE1 divided by the input current IB1. Okay. So now apply, yes, KCL at this node. So from this side it is IB1 and from this side it is IE1 and from this side it is IC1. So at this node A, you apply KCL, then you will get IB1 plus IE1 plus IC1 is equal to 0. So what is IE1? IE1 is minus of IB1 plus IC1. Okay, then now if you see, what is IC1? See this? IC1. This is the node and it gets divided like this and this. What you can write IC1? See this? Up to this node is IC1 and then it is divided like this. So you can write IC1 as, yes, one current is HFE IB1 plus another is HOE is the admittance. Admittance into voltage becomes the current. So it is HOE into VCE. HFE into IB1 plus HOE into, what is VCE1? See this? This is minus and this is plus for VCE1. Okay, so what is this minus VCE1? So if you take this terminal as reference, minus VCE1 is nothing but minus IE1 into RL1. Minus VCE1 is nothing but minus IE1 into RL1. Therefore, VCE1 is equal to IE1 into RL1. So now substitute simply IE1 into RL1. Okay, now substitute this IC1 into this expression. I will get IE1 is equal to minus IB1 Okay, then I am substituting total IC1 minus HFE IB1 minus HOE IE1 RL1. Okay, so from this I will take minus IB1 common, so it becomes 1 plus HFE. Yes, minus HOE IE1 RL1. Now, yes, take this term and take IE1 common. So if you move this term to this side, so it is 1 plus HOE into RL1 is equal to minus IB1 of 1 plus HFE. Therefore, AI1, that is nothing but minus IE1 by IB1 is 1 plus HFE by 1 plus HOE into RL1. That is 1 plus HFE by 1 plus HOE into what is RL1? RL1 is RI2. RI2 is HIE plus 1 plus HFE into RE. Okay, we can write it as, compared to this term, this is less, so neglect this. So totally it is 1 plus HOE of 1 plus HOE into RE. Okay, even here also, yes, 1 and HFE, you can compare 1 and HFE, so 1 is less. So totally your AI1 becomes 1 plus HFE by 1 plus HOE into HFE into RE. Okay, so totally this is your AI1. Listen repeatedly. Now we'll move to the input resistance. So this is AI1 current gain. Yes. What is RI1? Input resistance means input voltage by input current. Okay. What is that input voltage? See this? Between B1 and this C1, you have the input voltage called VI. Okay. So now what is VI? See here. Yes, you have to apply the total KVL like this. Because this is the input voltage that gets given to the total circuit. So RI1 is VI by input voltage, VI by input current, IB1. So now, yes, now if you apply KVL like this, in this path, you'll get VI is equal to, first one, IB1 into HIE plus HRE VCE1. So this is VCE1. Next, minus VCE1. And what is VCE1? IE1 into RL1. We already know the reverse voltage gain is very less. So this term contributes very less to this VI. So you can write VI as now IB1 HIE minus IE1 RL1. Therefore, RI, that is VI by IB1, is equal to IB1 HIE minus IE1 RL1 divided by IB1. So IB1 cancel, HIE. Then minus IE1 by IB1. Yes, we already know it is AI1. So HIE plus AI1 into RL1. Therefore, RI is equal to HIE plus AI1 into RL1. So that is RI1 is equal to HIE plus AI1. What is AI1? 1 plus HFE by 1 plus HOE HFE RE into 1 plus HFE RE. So totally your RI1 is HIE plus 1 plus HFE whole square into RE by 1 plus HOE HFE RE. Okay. And here also this is 1 plus HFE whole square RE. Very high compared to HIE. HIE typical value is 1.1K. So You can neglect this. So totally your Ri1 is 1 plus h of e whole square into Rd by 1 plus HOE h of e Rd. Okay, so this is your third one is voltage gain AV1. AV1 is, we know it as AI1 RL1 by RI1. Okay, just you substitute AI1, RL1 and RI1, I'll get AV1. The next one is output impedance. What's the formula for CC? RS plus HIE by 1 plus H of E. As this is the first stage, see for the first stage this is RS. Already you have RS, so simply substitute it. At the starting of Darlington emitter follower, I mentioned the speciality of Darlington emitter follower circuit. What is that? Darlington emitter follower circuit is having higher input impedance than a common collector amplifier. Okay. Now we can verify it or we can prove it. So now take the simple table is parameter and single CC and for Darlington emitter follower. First one will go for input resistance. For single CC, what is Ri? Yes, from the previous table, you can write it as take H of E 50, means for to calculate this table values, take H of E equal to 50, Re 3 kilo ohm, and we need HOE also 25 microampere per volt. Okay, fine. For single CC, what is Ri? HIE plus 1 plus H of E into Re. Even you can take HIE as 1.1 kilo ohm. So totally it is, so it is 154.1 kilo ohm. Single CC also it is high. But for this Darlington emitter follower, what is Ri? See this is Ri. 1 plus H of E whole square into Re by 1 plus HOE H of E Rd. So keep all these values, you will get 1.65 mega ohm. Okay, so compared to this it is, so approximately 10 times higher. Compared to the single CC, Darlington emitter follower circuit is having 10 times more input impedance. Okay, then I'll move to the current gain. So what is AI? Here it is 1 plus H of E, means 51. But what is here AI? Here I forgot to tell you one point. I mentioned this since CE cascade amplifier. So this is for single CC. For the overall Darlington emitter follower, what is the input impedance? Input impedance of the first stage. What is the output impedance? Output impedance of the second stage. Okay. Same way, the current gain of the single CC is this. What is the current gain of the Darlington emitter follower? You have to take the overall current gain. Okay. Overall current gain AI is equal to AI1 into AI2. For the second stage we got AI2 and for the first stage we got AI1. Okay, the total gain means, the total gain of the Darlington emitter follower means you must multiply these two gains. Same way, not only current gain, even for overall voltage gain, AV is AV1 into AV2. Okay, remember. So now, so what is AI1? AI1 is, say this is AI1. What is AI2? AI2 is 1 plus H of E. So AI1 into AI2 becomes whole square by 1 plus HOE H of E RE. So now if you substitute all these values, I'll get this around 547.5. Even if you see the current gain is 10 times more than the single CC amplifier. So What you can conclude? You can conclude that Darlington emitter follower circuit is giving more input impedance and more current gain than a single CC amplifier. What about the problem? Same. Here also they'll mention all the values like these things. These are needed along with that RS. Okay. So just substitute all these given numerical values into the expressions. Okay, you'll get all the voltage gains, current gain, input impedance and output impedance. That's all. Okay. So thank you very much.